Hello guys. In this lesson, we will continue our discussion of Chapter 2, Kinematics of a Particle Moving in a Straight Line. This is point 2.4. You can present the motion of an object on a speed-time graph or a distance-time graph. This means that we can construct a graph that illustrates the motion of an object moving in a straight line by plotting the speed of the object versus the time of motion in a speed-time graph, and the distance that the object passes versus the time of motion in a distance-time graph. These speed-time and distance-time graphs thus describe the motion of the object through time, so they graphically illustrate the motion. Let's check how these graphs are constructed as follows. First, these graphs are constructed using the x and y axis as the main axes for plotting speed time and distance time points. So we first sketch the x and y axis. The positive direction of the x-axis is to the right, and that of the y-axis is upwards. Time is always presented on the x-axis since it is a linear measure moving forward. So time in both the speed time and distance time graphs is presented on the horizontal axis of the graph. Next, speed in a speed time graph is presented on the y-axis and is plotted versus time on the x-axis. Motion starts from the initial point at time t equals 0, and this point right here is the point of intersection of the x and y axis, which is at 0 time and 0 speed. Now, for an object or a particle moving in a straight line, at the time of starting motion, at time 0, the object has an initial speed u. This is the initial velocity, designated as u, of an object starting motion from the point of origin. So we assign a point of origin where we set time t equal to 0, where the object would have some initial speed u. U is an unknown in this graph that we're constructing for the sake of demonstration. Then after time designated as time t, the velocity of a uniformly accelerating object will increase to v. V is the final velocity at time t, which is greater than u if the object is accelerating. Now, to connect the point of velocity u with the point of velocity v, we draw a straight line between the 2 points. Since we are studying an object moving with a uniform, constant acceleration. This straight line is the speed-time graph of a hypothetical object that we just sketched. The speed-time graph illustrates the motion of the object as it moves from the origin at time t equals 0 to another point at time t while presenting the change in its speed. So we analyze this graph as follows. At time equals 0, the initial velocity is u. Then after some time t, the velocity of the object reaches v. In addition, we can find the uniform acceleration of the object between 2 points, or the distance passed by the object between 2 points using this graph as follows. First, let's examine how we can find the slope of this straight line uv. So how can we find the slope of a straight line given 2 points on the line? We know that the slope of a straight line is the difference in y-coordinates, or the ordinates, divided by the difference in x-coordinates, or the abscisses. In this case, this is equal to v minus u, those are the ordinates, the y-coordinates, divided by t minus 0, and those are the x-coordinates, the abscissas of each point. This is v minus u divided by t. If we compare this to the formula of v that we already know, v equal to u plus at, then finding a using this formula from the equations of motion, we find a to be equal to, so we move u to the side of v and we divide by t. So a is equal to v minus u divided by t. Therefore, the slope of the speed-time line is equal to the uniform acceleration through time t, which is equal to v minus u divided by t. This is because the uniform acceleration is the change in velocity as a function of time. That's why the speed-time graph helps us find or illustrate the acceleration of the object too. So we should memorize that the uniform acceleration of an object is equal to the slope of the straight line speed-time graph of the object. So the speed-time graph of an object moving in a straight line in uniform acceleration is a straight line. And this slope is equal to the velocity v at time t minus the initial velocity u at time equals 0. Next, let's see how we can find the distance passed by the object from time 0 to time t. To find this distance, we should find the area under the speed-time graph, which is a line in this case. So we should find the area under this straight line connecting u with v. This is the area as shaded, which is an area of a trapezoid. And this shape, OUVT, is thus a trapezoid. But what is the area of a trapezoid? Well, the area of a trapezoid is equal to the first height u plus the second height from t to v, which is v, divided by 2, and multiplied by the base of the trapezoid, which is from 0 to t on the horizontal axis, which is t. As you see, the area of the trapezoid, which is the area under the speed-time line, which is basically a speed multiplied by time, is equal to u plus v divided by 2. This is an average speed, multiplied by the time t, which is equal to the distance. So we know that distance is equal to a speed multiplied by time. And this is the distance s that the particle passes from time 0 to time t. We already know this as the formula of distance from the equations of motion. Now to recap, whenever we have a speed time or a velocity time graph, we can find the initial velocity at time t equals 0, and we can find the final velocity at time t, and we can determine whether the object is accelerating or decelerating. So pay attention that if the speed time graph is an ascending straight line, then its slope is positive. Thus, the object will be moving in a positive, uniform, or constant acceleration. While if the speed time graph is a descending straight line, then its slope is negative, and the object thus moves in a negative, uniform, or constant acceleration, or what we call a uniform or constant deceleration. And finally, using the speed time graph, we can find the area under this graph, which is equal to the distance that the object passes between 2 points of time on the x-axis.